Okay, so we'll start now. Hi everybody, my name is Michalski, and together with my colleague Wojtek from SNOW.DOG, we would like to today say a few words about the best practices of deploying Magento on AWS. So I work in AWS as a solution architect with partners in Central Eastern Europe. I support them whenever they need any technical support related to work on AWS. So the presentation today will be split into two parts. During the first part, I will tell a few words about AWS and main services that customers and partners of AWS use when they deploy Magento on AWS. During second part, Wojtek will show you how those services can be put together in order to make a flexible, scalable, redundant and cost-effective solution of Magento on AWS. So what is AWS? So quick show of hands, who of you have worked with AWS so far? Okay, we have quite a few people. So don't worry, I won't be talking about each of them. We like to call AWS as a Lego blocks. Lego blocks that you can take from and compose a solution that you would do with the basically Lego blocks. At the moment, there are over 130 different services on AWS that you can pick from and use for your application, starting from the foundation services like storage, virtual machines, networking, through the containers and IoT apps up to the artificial intelligence or machine learning services. So these are all available for everybody at no upfront cost, no contracts to sign at the beginning, and basically on demand. To start the deployment, we need to choose a region or regions. So currently, AWS provides 18 regions all over the world. Each region consists of availability zones. Availability zone is a group of the distinct, independent but connected data centers that you can use to deploy geo-redundant applications with synchronous replication, for example. The numbers, as you can see on the screen, are showing the number of availability zones in each region. So, for example, in Europe, each of the regions have 3 availability zones. Once we select our region or regions, we need to set up our networking. So this is where Amazon VPC, which is the virtual private cloud, comes to the picture. It is isolated network environment in the cloud. You can define your IP ranges, whether you want public or private subnets. You can use NAT gateway as a managed service to make your servers accessing the internet from the private subnet, for example, and internet gateway when you want your servers be accessible from internet. Then you can also control all the traffic coming in and going out from the VPC by configuring and modifying security groups or network ACLs, depending on what you need and what's your goal. And so this is the picture how all those configuration can be put together in order to make a secure environment. Then we also have the load balancing options. So currently AWS provides 3 load balancers: application load balancer, network load balancer, and the classic load balancer. They can be internal or external, so you can put them in the front of the VPC to make it accessible from the internet, or you can use it as a load balancer within the application in the mid-tier, for example. They obviously support cross-AZ load balancing, which is basically distributing the traffic between the availability zones. And they have several different features like SSL offloading, built-in health checks, and sticky sessions. Once we have our networking set up, we have different storage options that you will use with Magento deployment on AWS, starting from the object storage. Then we have a block storage and file storage. So object storage, for the object storage, you might have heard of Amazon S3. It's one of the oldest AWS services. Started in 2006, so it is basically HTTP accessible object storage. It can be also accessed using API or SDKs. It's highly durable. It's designed to provide 11 nines of SLA, so you can be sure that your data will not disappear. It's fast and secure. You can use access control lists or bucket policies to secure each and single object within the S3 bucket. Then it supports different options for encryption. It's also scalable, automatically scales as your files grow, and then storage grows automatically. It's also inexpensive. To just give you an example, for 100 gigs of data stored on S3, you will pay only something like $2 per month. It also supports object lifecycle management, so you can define different storage policies to transfer the files between different tiers of the storage. You can also configure your bucket to replicate across the regions. And as I said just a second ago, different tiers are also available depending how fast you want your data to be retrieved. Then we have a block storage, which is the Amazon EBS, Elastic Block Store. These are basically the disks that we attach to the virtual machines, which are the Ec2 instances. There are multiple types of those disks, depending on how what is the type of the workload that you work with, whether it is CPU intensive, memory intensive, or maybe GPU intensive. You can choose from many different options when it comes to sizes or processors. Then all of them natively support redundancy in write cache. Obviously, encryption options are available as well. All of them are scalable, so you can grow the disks while they run, and can be moved between two EC2 instances. So you can basically detach and attach the disk from one instance to another. And the latest improvements to the EBS disk allow to support up to 80,000 IOPS per EC2 instance. Then we move to file storage. If we want to have some file system, we can use Amazon EFS, Elastic File System, which is the managed file system, fully managed by AWS File System. It's NFS version 4 based. It's also, as all of the most of the services, is automatically scalable and flexible. You will only pay for what you use. Also, it supports native redundancy, so it's deployed automatically across three availability zones. So, in case of losing one availability zone, you still have the storage and the files that you put on the NFS. And it supports thousands of concurrent connections. Okay, so once we have our networking setup, we have our storage, then we need some virtual machines. So in Amazon Web Services world, they are called EC2 instances. These are basically compute instances which you can also provision in multiple different types. Whether you need a lot of CPU or a lot of RAM or GPU, you can select from many different options. You can obviously have many different operating systems, whether it is Linux or Microsoft Windows, including Windows 2003, if someone still needs to use it. Obviously, there are options for auto-scaling and auto-recovery. So these are one of the main advantages of the cloud. It obviously, as I mentioned before, you can attach block storage to it, which is the basically EBS disk. You can back up those disks with snapshots, which are then stored on S3, and you can have them. You can pay in different options. By default, you get them on demand, but you can also use the spot instances, which is basically stock market for the computing. And then you can also use reserved instances, which is, by this you can save up to 75% by telling AWS that you want to need, let's say, 5 virtual machines for 1 year. And this is how such setup can look like. We start from the AMI, which is the image of the instance. Then we can run it, stop it, and then we can deploy it between in different AZs, attach the EBS disk to it, take a snapshot, and then snapshot will be stored on S3. Then databases, because in order to run the Magento on AWS, you need to also have a database. So there are 2 different options that you can deploy a database on AWS. Traditionally, you would go for the EC2 instance. You would take, let's say, Amazon Linux, then you would install the database on it, MySQL, but you need to patch it, you need to maintain it, you need to take care of it. This is why Amazon Web Services provides RDS, which is the Relational Database Service, where AWS takes care of all heavy lifting for you. So you don't need to take care about the backup, you don't need to take care about the patching or anything. You just put your data in, you just pick up the engine. There are 6 different engines available right now. MySQL, PostgreSQL, MariaDB, Oracle, Microsoft SQL, and Amazon Aurora. As I said, it provides automatic backup. You can restore your backup to point in time, back 35 days. It supports cross-region snapshots, so you can transfer your data from one database to another region and then bring up the database in another region. It supports encryption in transit and at rest. And it also can be configured in multi-AZ failover mode. So in case something happens in one AZ, then the database is automatically failed over to another AZ. It also can be scaled with just click of the button when it comes to storage, and you can also have it in the provisioned IOPS mode. Then if you need to scale it horizontally, you can have up to 5 read replicas, which will help you to scale the application when it comes to reads. Then one of the options for the RDS is Aurora. It's Amazon database engine compatible with Postgre and MySQL. It's, according to our benchmarks, is 5 times more better performing than MySQL and up to 3 times better performing than Postgre. It obviously supports encryption, different encryption options. It can auto-scale automatically up to 64 terabytes, so you don't need to take care about the scaling. It's fault-tolerant and self-healing for storage. It has an option for backtrack, which means that you can move back your database up to 72 hours without needing to restore the database. So you just click a button and then it takes you back as long as you need, up to 72 hours without restoring. It takes just a couple of seconds. Encryption, I already mentioned about it. And then there's an option for serverless, which means that first of all, there is no server to manage. You pay only when your application is using the database, and it scales automatically. So there is no need anymore to scale not only storage but also compute. And it can have up to 15 read replicas, so it's 3 times more than all other options in RDS. And there are 2 more services which are typically used with Magento on AWS. Elastic Cache, which is basically in-memory cache in the cloud. It supports Memcache and Redis. For Magento, usually Redis is used. It's also fully managed. It can be multi-AZ, and it also can support up to 5 read replicas. There are also encryption options if you need so. And Amazon CloudFront, managed CDN, available in over 120 locations all over the world right now, including Poland, Warsaw. You can specify different options. You can geo-restrict it. You can integrate it with web application firewall. It supports static file delivery. It supports also static and dynamic website content delivery. And obviously it's available in pay-as-you-go pricing, so the more you use it, the more you pay, but also the more you use it, you can get a more discount. So yeah, these are the services that are typically used with Magento, and now I would like to hand over to Wojtek, who will show you how those services can be put together.
Okay, thank you, Rafał. I will tell you more about a practical use of what you just heard. It's for Magento 2 deployments. There is a diagram. It looks complicated at first, but we will go through each of the elements and talk about it. Sorry, I didn't introduce myself. I'm Wojtek from SNOW.DOG. I do the infrastructure here. It's a mix of DevOps, SysOps, and problem solving. So, going further, this is the basic VPC architecture. It's laid out in one AWS region. This is, as you can see, high availability architecture. There are 2 availability zones used here, and we will keep till the end of presentation with these 2 to not clutter the images, even if it's cluttered already. You can see the public and private subnets. It's divided into these in both availability zones. There is Internet Gateway on the top, placed in public subnet, and managed net gateways, also placed in public subnets that are used by the private subnet hosts to communicate to the internet. The Internet Gateway works for communicating to the public subnet, the NAT gateways, private. Managed net gateways also have Elastic IP attached. This is how the routing typically looks. Let's say the network has 10.0.0.16 CIDR. So public, you send local traffic through the local, and the internet traffic to the internet gateway, and private just goes to the NAT gateway. Local is obviously local. Next, we will look specifically into the public subnet, where we have and the basin hosts. So this part is publicly routable, so it's equipped with Elastic IPs, so you can get directly from internet to it. The Bastion host's task is to provide administrative access to environment. It's the only way you can enter the environment, typically by SSH access. There is an autoscaling group just to make sure that you have access to this environment through the healthy servers. Also, it spans across the availability zones if you need high availability to connect on demand. Security groups. We use it for access control. It's attached to the based-in host group, just allowing SSH access, typically port 22 from your known IP ranges, let's say Office. Also, the logging. The logging is important on based-in hosts, which actually are hardened Linux instances. The idea is to log everything that the person connecting through the based-in host does in a shell. So you log it locally, of course, but if, let's say, the malicious user does the privilege escalation, he can easily remove the logs and cover his tracks. So it's good to actually push the logs somewhere else. There are services in AWS like CloudWatch or S3. Moving further, we'll go with a private subnet. Here on the top you can see the external load balancer, which is the internet-facing load balancer. It serves also as an SSL offloader. Next is Varnish server's autoscaling group. Just below it there is internal load balancer. It's in a private section of our network. And there is Magento web server's autoscaling group down below. To simplify this, I'll just take the one Varnish server out of the group, and before I move on to implementation, I will try to describe how elastic load balancers work. So it's not just the typical round robin, for example. It's more complex than that. As you can see, there are autoscaling groups of the node balancers, load balancers nodes placed in both AZs. And the Amazon's DNS service route 53 maps the elastic load balancer's name to the node's IPs. In short description. So it is important that we keep the addresses of the load balancers up to date. And Varnish can do the load balancing. Okay, so it could ask the DNS about the load balancer's IP, current local private IP. But there is one problem. Varnish was designed to be very fast, performant, and once it does, it only unfortunately resolves to the one IP. And what's worse, it uses it until the end. And it's not good. Actually, this is the obligatory cat meme for the presentation. Okay, so the Varnish has to communicate to the web servers somehow, and there are things that we can use to help him achieve that. So, of course, we can use let's think some script that is called from cron job, and it asks the DNS for the nodes of load balancers IPs, and it updates the Varnish configuration and reloads it, so the Varnish has the current addresses. But it's not efficient, might work, but there is a better solution, and this is putting the Nginx behind. Nginx can resolve the domain name to multiple addresses, but there are some pitfalls you have to watch out for, because it can also behave the same as a Varnish, so resolve to one address and remember and use it forever. There is some part of the configuration. The Nginx doesn't use the system's DNS resolver. You have to define it in a configuration. On AWS, the DNS server is at the base of this of your VPC subnet +2, and you can see there is a part with setting the variable, which is then used in a proxy pass call. And this prevents, this makes the Nginx resolve the domain when it actually expires. So it always uses the most accurate current ones. And yeah, the way we should do it is probably with Nginx. Next, the health checks. This is pretty important, but actually we should delegate it to load balancers as they have such a feature. Of course, external load balancer checks health of our Varnish servers group. Internal load balancer checks health of Magento web servers group. There are more details to that, but we don't have time for this now. So just scratching the surface. Next, we move to the web servers. We recommend the Nginx. It's very fast, scalable, low footprint. Performance is top-notch. It's C10K ready. And even under heavy load, it behaves very well with very low utilization of CPU and memory. What more? PHP. Yeah, we need PHP. Nginx talks via fast CGI protocol with PHP. Currently, we use 7.0 as there were people that found that 7.2 is giving them actually currently the lower performance, like our friend Winston. It's good to configure the PHP on a sock instead of port. It's better performance. The web server and PHP are on the same host. We don't have to worry about network connectivity. And Unix domain socket does not have as much network overhead as TCP port. It's like 30% of network time. It's much. Next, logs. As we have it in autoscaling groups, the instances can be destroyed any moment. So you want to know what's happening, you just push the logs to your central storage for analysis in one place. Monitoring, of course, it's good to monitor your web stack. AWS gives you some tools for that, but I think it's CloudWatch. Yeah, and it's good, but there are also external services that actually build on top of CloudWatch APIs, and we all know that New Relic is very good and you should go with it. Next, they are all launched in autoscaling group. So we want to aim for the shortest time from instance creation to the healthy up state when actually the application starts serving the requests. How to do it? Well, custom AMIs. AMIs are amazing machine images. They are like the let's say Cloud ISOs by Amazon. You can, of course, build your image. So when doing that, you might want to think what to put in it. Of course, the first idea is to put all the tools, all the web stack in it. Also, some people think, should you put config and code in the image? Should it be baked in? Well, it all depends on your deployment strategies. How do you want your deployment pipelines to work? So you might want to hook up to your CI/CD pipeline, let's say tools like Packer or whatever you want to do, and build your images. But you can also use the AWS code deploy services. They really help. You can do the blue-green deployments. But of course, it all depends on your needs and how you can join it with your current pipelines. So we just talked about Magento web servers. There are more Magento web servers, and it's the admin group. Good idea is to put it on a separate load balancer, on a separate domain. And Magento, you can put this on default store view and configure it to only serve the admin purposes. The client-facing store views would be as sub-stores on a different domains. Of course, you attach the security group. The access is limited, let's say, to your admins, shop admins addresses, your office, whatever you want. You skip varnish cache. You want everything to be up to date without worrying if varnish maybe cached something. dbconfig, you configure only database masters. We don't want any replication lag, even if it's 20-30 milliseconds. Longer execution times and more memory for PHP. As we all know, admin tasks need more resources. Cron jobs. Well, people also tend to put cron jobs on admin groups. Okay, I see my time is running out. I will try to say it faster now. So there is a shared data media. There is a distributed system. You have multiple nodes that need to share some data. There is a classic approach, as I call it. It's a network disk for media. You have an NFS, Gluster, Ceph, you all know it. Amazon has EFS, as Rafał told. EFS performance issues. Well, we all know that Magento does ask a lot about files metadata, and on a network drives, kernel, when calls stat, it's actually syncing the drive, so there is a lot of overhead. But good news is that provisioned throughput is now available, so you can have all the performance you want. There is also the other approach, I call it the API approach, is object storage service. Amazon has S3. How to keep media in S3? Well, you definitely want to keep it in private buckets. The transfer is inside the AWS network. You can use, for example, some module for example, one that overrides media in database, or maybe some of S3 file systems in user space. I don't recommend that. Performance is not so good, but you might do some experiments. Maybe some are better now. Bonus that comes with S3, you can easily use CloudFront CDN, which further decreases the load on your instances. Next, the databases. The RDS service has MySQL, it has Aurora and Aurora Serverless, which is generally available now. Magento can work with 3 of these. Generally, I recommend Aurora. It's more HA, more replicas can be launched, static replication, let's say latency around 20 milliseconds, because instances share the underlying EBS drive. Magento Commerce has a CQRS implemented and split databases feature. We can use it on some shops that need it. Of course, set up a master and slave nodes for read and write. What's more, the Redis cache. There is application cache and sessions storage. We put it in a Redis. Elastic Cache is the service, and just good idea is to set up 2 clusters, separate for app cache and separate for sessions. Multi-AZ with auto failover, and just remember that the module that supports this in Magento does not support the cluster mode, so disable it when creating the clusters. Emails, it's the simple email service. It's easy to configure. It signs DKIM. It has SNS notifications. But of course, you can, if you need to have the history, what emails were sent, use external services. So summing up what's next, we've heard Andrew's talk about Kubernetes. It's very good, so go with containers, tell me what you can do with it, and that would be it. Thank you for your attention.